Are you looking to set up the ultimate S-Tier Wi-Fi security experience for your home lab or business network? Or maybe you're just sick of people sharing your Wi-Fi password with each other, maybe not even realizing it. So today we're going to set up the ultimate in wireless security using WPA3 Enterprise with certificates. And we're going to set up these certificates so that they're resident on the Trusted Platform module of the device, the ultimate way to keep your network secure. So come along with me on this adventure. Quick note here, guys. I'm really happy to work with Smallstep to produce this video. They make an open source certificate authority that I've used in some of my other videos on security. In this video, I'm using their managed service online, which is free for home lab scale users. However, everything I do in this can be done with a combination of their open source self-hosted certificate authority in combination with pre-radius. So thanks to Smallstep for this, and let's get on to the video. So our end goal for EAP-TLS is to come up with a system where both the clients of the network and the network itself can securely identify themselves for authentication purposes. So the technique this is based on is called public key cryptography, expanded into public key infrastructure. So in public key cryptography, I have a private key that I keep to myself, and I have a public key that I share with the world. I can use my private key to sign a piece of data in such a way that anyone with my public key can verify that it was me and only me who signed that piece of data. Expanding on this, we have a certificate authority somewhere in our organization. It's at the top of our chain of trust. The certificate authority then signs certificates of lower level entities using its private key. So if someone trusts the public key of our authority, they can look at the certificate that includes the lower level public key and was signed by the higher level private key and validate that this lower level certificate is trusted by our root. So expanding on that further, I, as a client of the network, can ask the certificate authority to please sign my certificate. It'll include my username, and it'll be based on my private and public key. So then, when I connect to the network, I can provide the certificate. This shows the network my identity, and also that the root certificate authority trusts me. As long as the radius server trusts that authority, it will then trust me and use that identity information, making its decision. So I actually did a video a little while back on setting this up for HTTP-TLS certificates using Smallstep Certificate Authority. Link up here for that video. And so this is similar in concept, except instead of securing HTTPS connections, we're securing Wi-Fi. So for this video, I'm going to again use Smallstep, but this time I'm using their managed service online. So Smallstep produces an open source certificate authority server software, which is what I used in the other video. But they also produce a software as a service to manage your public key infrastructure, manage your client certificate distribution, things like that. So they integrate with MDM or mobile device management providers so you can roll out certificates to all of your devices as part of the enrollment process. They support procedures for the devices to have their certificates signed, like SEP, which we're going to use in this video. And so they provide a little more functionality than just the command line server alone provides through their web UI. Nevertheless, if you want to do this entirely self-hosted, it's certainly possible to implement all of this using the STEP CA server combined with free radius for the Wi-Fi authentication side. So now, how do we set up Smallstep to be our certificate authority, and how do we add that as a radius server in Unify? So coming over here to Smallstep, you're going to have to sign up for an account. You can enter your team name, company name, name of your home lab, whatever. So I name mine Appleards Adventures. You can name it whatever you'd like. This is just your team name. I am going to be using the free plan for this, so it doesn't cost anything as long as you stay at the home lab scale. If you look at their licensing, you can see what it costs if you grow from there. Biggest limitation is you can have one admin if you're a home lab scale or free tier user. So once you're logged in, we're greeted with this screen here, so we can see all the different things. Big thing here is in Certificate Manager, we have authorities. And so I have Smallstep agents, Smallstep accounts. And so like in my past video, this is the root certificate. So Smallstep has created two roots here, and I can add certificates down below these roots. So if I click on the agents here and I view it, a neat thing about the Smallstep software as a service or managed system is it actually tells you how to do everything in the command line. And the command line is open source, so you're free to use it on your own, self-host it. So like here, if I want to generate a new certificate, I could do it through the web UI here. I could choose the subject name, choose the expiration. but it tells me the equivalent command here. And so if I type in, I don't know, so right now it says 3 months. If I bump that down to 2 months, 1 month, it updates the example command here with the exact command. And you can, of course, use the step.ca command with a managed certificate authority from Smallstep, or you can run the Smallstep certificate authority self-hosted yourself too, and the commands are the same. So final thing we need to get our network set up to be able to accept clients is we need to add it as a Radius server. So Radius is a protocol that allows network authentication devices, most commonly access points and switches, to forward authentication information from clients. So it's part of 802.1x. So in .1x, a wired client on a wired switch can authenticate to get access to a switch port. Similarly, a wireless client can get access to a Wi-Fi network. So that connection between the switch or the access point is called Radius, and we need to set that up on both sides. It's not the most secure protocol, so generally Radius relies a lot on IP address filtering, and that's going to be set up here as well. So now in Smallstep, I'm going to go to Devices, and I'm going to add a collection. I'm going to say Apple OS endpoints. So just because it says Apple doesn't mean we're tied to only using Apple devices. Basically, it means that this is going to generate Apple mobile config files, which you can directly import into a Mac or iOS device, which is easier. You can still use like a P12 file to import into all other types of devices. So here we can give it a name, Wi-Fi network, and I'm just going to click through here, and I'm not going to give it any registered devices. So here we are. So now we have devices and accounts. And this might seem a bit confusing, but a device is a hardware module that has access to our network. So this would be an Apple mobile config in this case. An account is what we actually use for Radius. So that's the server side that authenticates the devices. So we're going to add an account here. We're going to click Wi-Fi and continue. So now we need some information about the network. So we need the IP address that our access points are going to be using to connect to Smallstep. This is usually going to be our public IPv4 address. Currently, UniFi does not support IPv6 for Radius, so blame UniFi for that. So I'm just going to click Use My IP address. We'll figure it out. So next up, we need an SSID. Smallstep is going to generate and automatically renew a certificate for the access point. So we need to know the name of the SSID because that's part of the certificate. And it's not a hidden network, and it's an auto-join network. So those are the settings. So you can choose accounts or agents. I'm going to choose accounts. We could say it's not protected, and we'll do a 4096-bit key, 90-day lifetime, and then we click confirm. So once we confirm that, we get a bunch of shared secret information we need to send to UniFi, so UniFi can authenticate to this Radius backend. Coming over here to UniFi, we get onto Settings, Profiles, Radius, Create New. So we're going to call this Smallstep. We can use this for wired or wireless. So now we need the IP of the server. So coming down here, this is Smallstep's IP, and it's on port 1812, and it has a secret. So we'll add that, and then we also have accounting. That's on the same address, and it also has the same secret. So now we have our server set up, port, secret, and let's apply. So the final step in setting up our network side is we need to switch it from being the old, less secure WPA2 pre-shared key to our new WPA3 enterprise. So now that we have the Radius server, we can do that. So in UniFi, I come over here to Wi-Fi, and I click my network. This name better match what I typed in earlier. We can ignore the password because we're going to get rid of that soon. So I got to click manual here to do advanced setup. And we're going to go down and change security protocol to WPA3 Enterprise. And so then we have some other options we can play with. So you can choose to enable 192-bit mode. This can only be used in WPA3 Enterprise and only with TLS. So I'm going to enable that. Future AppLard here with a little bit of a footnote. 192-bit security in Wi-Fi is a bit of a dark art of crypto. So to do proper 192-bit mode, we need to use elliptic curve cryptography with a 384-bit key size, which is double the 192-bit security that we get. And so that means 384-bit elliptic curve Diffie-Hellman and elliptic curve digital signatures. It also means we need to use AES-256 on the link. This is a bit of a sticking point for a lot of devices that support WPA3. So most devices could add support for WPA3 with a firmware update. Most devices that get firmware updates have already done that, because it uses the same AES-128 the previous WPA2 did. But now, to use 192-bit mode, it means the hardware possibly needs to support AES-256 once that's being done in software. So a lot more devices won't be able to support 192-bit mode than would otherwise be able to support WPA3. So in my particular problem, I have an iPad 5th gen. It supports WPA3 Enterprise, but it doesn't support 192-bit mode because it doesn't have the hardware to support 256-bit AES. So just a footnote on that if you're going to choose between 128-bit mode or normal and NSA grade 192-bit mode. Now back to the video. We also have to select a radius protocol, so I'm going to choose Smallstep for that. And now we'll save. So now our network should be broadcasting that it supports WPA Enterprise. Our client should see that and try to do negotiation, but none of our clients have certs yet, so they're all going to fail. So let's see how to fix that problem. So now that we got our network set up, how do we generate some certs for our users? So fundamentally, what we need to do is we need to generate a private key. We need to sign the certificate for that private key at our certificate authority, and we need to install that on the operating system. Now, Smallstep has a CLI, part of their open source toolset called Step CLI, and that will do all of these things, but you have to install it on the target machine. So we'd rather not do that because I don't want to go around installing software on all my machines. So instead, I'm going to export a key pair, which is a private key and a certificate, from the web UI and send that over as a P12 file. Now the downside to this is the private key is not generated in place, it's generated somewhere else and then transferred. And we would like to minimize transferring of the private key. So the P12 file is encrypted, but just with a basic password. So it has some protection, but you're going to want to not keep that P12 file around too long. So over here in Smallstep, I got under my certificate authority, and I'm using the accounts authority, so we'll go here and we will view details on that one. I can say get a new certificate. So this tells me the step CA command to get a new certificate if I need to. So if I just type this stuff in here, so I could say generate it for my laptop, we'll say 3 months. So it has the command here. If you were to use the CLI, you'd use that command. And I'm just going to click Get Certificate. Yes, authorize. So now it generated me a private key and a certificate. I can only download them once because they're not stored by Smallstep. Well, the certificate is, but the private key is not. If you're using the CLI, it'll generate it locally, sign it at the CA, etc. If you've already got the CLI set up. So I'm going to go ahead and download these two into my downloads folder, and there they go. So now that private key is just unprotected, so we need to fix that. So coming over to the terminal, I'm in my downloads folder. I have my key insert, and I'm going to use OpenSSL to merge this key and this cert into a single P12 archive. This is a really common format that most operating systems should accept. Mac OS, Windows, all those guys, they'll love your P12 file. You're going to want to add a password to it. Some devices require a password. iOS, for example, will not accept a P12 file without a password. So a command is basically OpenSSL pkcs12. So pkcs12 is like the full name of P12. Export in key, insert, and out P12. And I can give it whatever password I want. And there we go, I have a P12. So in case you're wondering how that looks to install on macOS here, so I got the cert and the key, and then I generated the P12. I just double click on it. It says, do you want to add this file to your keychain? So I'm just going to add it to my login because my test user doesn't have permissions to add to the system. So now it asks me for the password for the P12 file, so this can decrypt it. And there we go, it should be added. So now that I have the P12 key, it's not associated with the Wi-Fi network. So I still have to connect to the Wi-Fi network and still tell it to use that key. So we'll connect here. So now it wants me to either enter a username and password or a certificate. So I just added Apple or laptops. We'll pick that certificate and click OK. So now it's telling me I need to examine the server certificate. Because I didn't add a root certificate for my certificate authority, I have to look at the certificate from the Radius server and see if I want to trust it. So in this case, the Smallstep Radius Intermediate CA is not trusted. So I could also go and add that root key to my system trust, or I could trust it. It's going to ask you to trust it again every time this changes, so it's kind of a pain. If you want to add the root certificate, you can pick it up from the page where we created the radius setup. So we get on here, we have all the radius parameters. We can come down here to the root certificate and download it and import that into our system keychain as well. So now we have a way to generate these P12 files. You can take these P12 files and they should work on pretty much any operating system that supports WPA Enterprise. Windows will take them, Linux will take them, Mac OS, iOS, they'll all take your P12s. But for Apple devices specifically, we have an even better way. So what we'd really like is if we can generate a private key on the device and then send off that public key to get signed into a signature by our certificate authority. And so that means we have the option potentially of storing that private key in a secure enclave. So some systems such as YubiKey support this method where they can generate the private key in the secure hardware. Apple also supports this very recently, although software support's not quite caught up there yet. The TPM2 standard also allows this, although I don't think Windows supports it, at least not for user visible keys. So anyway, to make this work, we need the certificate authority to trust us to sign our public key. And there's a couple ways we can do this. So the method we're going to be using today is SCEP. Essentially, Smallstep will generate for us a config file. It's called a mobile config. That mobile config includes all the information Apple needs to configure a wireless network. So that mobile config contains the SSID of the network to connect to, any of the public keys for the network itself, as well as an endpoint to connect to via SCEP so it can generate its signed certificate. And it also includes a secret that it uses to authenticate to the SCEP server. So after we're done with this file, we probably should delete it so someone else can't sign their own certificate. The other option is called Acme. And you may have heard of Acme before because it's used with Let's Encrypt to sign certificates for web servers. And the same exact protocol can also be used to sign certificates for clients. However, this deployment is really quite new. Apple just announced support for it in the summer of 2023, and they haven't rolled it out yet to non-mobile device management or MDM vendors yet. So that's why we're using SCEP, but in the future, Acme might come along and get better software support, and then we can use Acme instead. So anyway, to set up a device for SCEP, we need to create that device in Smallstep, and we need to use its serial number. So over here on the iPad, we need to get our serial number, and then we need to bring it into Smallstep. So in case you're curious, on Mac OS, this works for Mac OS, iOS, iPad, all that good stuff. It's under Settings, General, About, then there's serial number. We can just copy that. Then we can whip on over to Smallstep. Now I'm using Safari for this. Apple is pretty picky on where you can download and import security keys from. So for example, they have to come from AirDrop, Files, Email, Safari. Other apps can't always add certificates and change the trust of the device. It has to come through a more secure channel or from another device, like a file transfer. So here in Smallstep, I can click on my Wi-Fi network. This is where I've already set up an account for my Wi-Fi. But now I'm going to go to Devices. I'm going to add a device with the identifier of my serial number. Add device. So I'm just going to paste that on in here to the box. Add device. So now it's going to generate a mobile config for us. So if I click View Device, now I can see the device information, and now if I click on Accounts, it'll generate a mobile config that ties this device to that Wi-Fi account we created earlier, Bill Y. So I click Configuration Profile, and now it's going to download a mobile config file. And this config file tells the iPad or the Mac or whatever how to connect to the SCEP server so that it can get its certificates. So in addition to that download, we also need the root certificate, and we need to install that in the root of trust on this iPad here. So I'm going to go back to Devices, go to my Wi-Fi network. Now I'm going to go to the place where I configured my radius before. If I scroll all the way down to the bottom, it's got some links for me for the root certificate, root and intermediate bundle. So I'll just download the root certificate. We'll download that. Now for some reason it downloads this as a text file, so we have to convert it to a SIR file. Just change the extension. If you airdrop this or something, you can just name it a SIR file properly. So over here in my downloads, I can click on the 4 dots and say View Options, Show All Extensions. Then I can go to the certificate and rename it. And we're just going to get rid of that text at the end. It's going to ask us if we're sure, and we're sure. Now it's a certificate. So now we can double click on that. Now the profile has been downloaded. So flipping back over to the Settings app. So it's giving me the option to install this profile. So it's Smallstep accounts. You can see details, where it came from, and we're going to install that. So this will add the root certificate from our Smallstep certificate authority to this iPad so it can trust things. So if you're curious later, you can go to General, About, and scroll down to Certificate Trust Settings. And your new root should show up here, and then we can enable it. Now the enrollment has to be done over the internet. So if your iPad has like cellular, that's fine. If your iPhone does or whatever. If it doesn't, you're going to have to temporarily configure your network for some other security or use your guest network or something like that. So now I'm going to double click on the mobile config, and it says review the profile and install it. Yeah, sure. Flip back over to the settings app. It says profile downloaded, so we're going to look at that profile. And we are going to install it. So this mobile config includes the SSID of the network, the instructions for how to go through the SEP process, and the intermediate certificates it needs. So now that I've installed this profile, this device should connect to the Smallstep SEP server, do the device attestation process, and get its certificate signed for this network. So if we're curious here, it looks like it got a SEP certificate. It looks like it was successfully signed. That's a good thing. So the private key for this certificate we just got over SEP is part of the secure enclave of this device, so it can't be exported. This device generated the private key locally, then it went out through the device attestation process and got the server to sign it. So one last thing, so we added that root certificate. That was the certificate that the SEP server itself used, so this could connect securely to the server. Now that we added the mobile config, it was able to do the SEP exchange using that certificate, and the mobile config added a new certificate, the root certificate for Radius. So I have to come back to certificate trust, click on that guy. Yeah. Now we should be ready to connect. At this point, I spent a very long time pulling my hair out until I finally realized that my rather old iPad doesn't support WPA3. That was my problem. So now I can go into Wi-Fi, Bill Y the Science Fi, he just pops up, he works. No entering a password, there's no password to enter. And go in, you can see he's got an IP address, he's got an IPv6. So yeah, it works. I did the same process on my phone, my laptop. It's going great. So at this point now, I've got my laptop and my tablet connected to my Wi-Fi with WPA3 Enterprise. I went down to 128-bit mode so the older tablet could deal with it. And everything's working pretty well for me. So there are a couple quirks of the setup you should be aware of. The first one is that, unlike passwords, certificates do expire. I mean, some people expire their passwords, but current guidance is to not expire them. So anyway, these certificates in this demo have a 3-month expiration. So in 3 months, your computers will stop being able to connect to the network because their certificates are invalid. And the solution to this is to rekey them periodically. So if we had a mobile device management provider, we would just let it deal with it. But none of them want to talk to someone at such a small scale like me, so I have to do it manually. If you're using the P12 process, you just run through that process again, get a new cert, delete the old one, add the new one. You can do that over the Wi-Fi network because your old cert should still be valid. If you're using the mobile config method on Apple devices, you just run that same mobile config again. It'll go through the renewal process and be fine. Since we're using Smallstep's Radius server, they'll take care of renewing the Radius server cert for us. If you're running your own free Radius server with self-hosted Smallstep, you'll have to write some sort of automation that periodically rekeys the free Radius server, which if you're doing that probably is not terribly difficult. Of course, all of this can be done using just the open source Smallstep. They just add a bit more plumbing with the web UI that makes it easy to work with. I'm really glad that Smallstep was able to work with me to make this video happen. There's some really cool guys doing some cool stuff with open source certificates and stuff like that, so go ahead and check them out. Also, a fun fact to learn while making this video, the very popular ESP32 family does have support in software for WPA3 in 128-bit mode using TLS. If you like to use ESP Home, for example, you can set that up. It'd be nice if there was a way to automatically generate certs every time you provision a device or compile it, but they don't have that. You just have to copy and paste the cert into your YAML for that. Maybe that's something someone could add in the future to them. But basically the ESP supports it, so there's no reason IoT devices can't support WPA3 Enterprise. It's just bad firmware from the vendors if your device doesn't support WPA3 Enterprise, at least in 128-bit mode. 192-bit mode does require some more extensive hardware changes than just software, so that's more understandable. So as always, if you like my video, I have a Discord link down below. You can chat with me about Wi-Fi, networking, computer stuff, IPv6. If you want to tip me at all, I have a Ko-fi link down below. And as always, I'll see you guys in the next adventure.